important is try to think what type of batteries are the batteries that I need in this particular case. Remember that in this example, the recommendation is 48 volts. How can I get 48 volts? Yes, if you connect, for example, if you have batteries in 12 volts batteries, you need to connect 1, 2, 3, 4 batteries in series in order to get the appropriated 48 volts. But remember, when you connect in series, what happens with the intensity? Yeah, the intensity stays constant. In that particular case, I have 100 amps, I have 100 amps per each battery of 12 volts. If I connect 4 batteries in series, I have 48 volts, but 100 amps. Okay, let me verify how many amps I need in total in order to solve this situation. We found the Feature Panda solution. The Feature Panda solution offers a 20 kilowatts motor, electric motor. And that solution, the proposal of that solution is the electric motor receives the power from the inverter, and the inverter receives the power from a group of batteries. This is the group of batteries. The group of batteries feed the inverter, and the inverter provides the AC output. In other words, I need an inverter. That inverter provides in the output, in the AC output, 20 kilowatts. In the output, 20 kilowatts. And in the input, this is the output, 20 kilowatts in the AC output. This is the output, AC. And this is the input, DC. Alright, in the output, that inverter provides 20,000 watts, 20 kilowatts. How much power I need to put in the input? You need to put exactly the same that you need in the output, plus some additional power, because internally the inverter dissipates power, heat or drag, or you dissipate power. How much? Like 17%. For that reason, I need added in the input 20% additionally for safety factor. I wanted in the output AC, 20,000 watts. Okay, I need in the input, I need 20 kilowatts plus 20%. I need 20,000 times 1.2. When I want to add it, I multiply times 1 point something. I need added 20%, I multiply times 1.2. I need added 40%, I multiply times 1.4. Alright, in this particular case, 20,000 times 1.2 is 24,000 watts. This is the power that I need in the input, in the DC input. This is the power that I need in the group of batteries. Okay. And also I need to configure that group of batteries in 48 volts. Okay. The voltage of that group of batteries should be 48 volts. Alright. And the power, what is the formula for power? Power is voltage times intensity. You remember the Ohm law? Alright. Power is equal to voltage times intensity. What is the unit of the power? Watts. Okay, 24,000 is equal to 48 volts times the intensity. That's the question. Okay, in that case, the intensity is equal to 24,000 divided by 48. This is 480 amps. Okay, I am going to round it up to 500. 500 amps per hour. This is the capacity in amps per hour of my group of batteries in the input of the inverter. Okay, 500 amps. Alright, what is the meaning of that? I need 500 amps per hour at 48 volts to supply 20 kilowatts during 1 hour. However, what is the recommendation with the batteries? Discharge the batteries no more than 50%, ABYC question. Alright, in that case, I have with that group of batteries, I only have 30 minutes of a constant operation of the equipment, the system. Alright, in order to discharge the batteries no more than 50%. Of course, if you use lithium batteries, you can discharge those batteries a little more, because those batteries have the ability to recover again, and those batteries are not destroyed if you discharge those batteries completely. Yeah, this is other advantage of those batteries, the lithium batteries. All right, this is the configuration. I need 500. The first scenario is using batteries of 24 volts. Remember that we need 48 volts in total. Okay, suppose that I am going to use the batteries of 24 volts. You remember in the previous slide, those batteries, the capacity is 24 volts and 50 amps each one. Okay, if I connect two batteries in series, I have 48 volts, 50 amps. 48 volts, 50 amps. How many batteries I need? I need one group, two groups, 3, 4, 5, 6, 7, 8, 9, 10. We need 10 of those groups. In total I need 20 batteries. 20 batteries in order to get 48 volts. In order to get 48 volts, 500 amps. In order to get 48 volts, 500 amps, I need 20. I need 20 batteries. 20 batteries of 24 volts, 50 amps each one. It's a lot of money. For example, I am going to take the decision with the lithium batteries. How much is the price of each battery? Each battery is around $980. This is 20 batteries is around $20,000. This is a lot of money with 24 volts batteries. Let me check what happens if I try to configure it with 12 volts. With 12 volts, remember in the previous slide, the 12 volts batteries, lithium, they have the ability, in that particular example, each one to storage 100 amps. Alright, 12 volts 100 plus 12 volts 100 plus in series is 48 volts 100 in each row. Plus the second one, plus the other one, plus the other one, plus the other one. At the end I have 48 volts, 500 amps, but I need 1, 2, 3, 4 times 5, I need again 20 batteries. Once again, in both scenarios, using batteries of 24 volts or using batteries of 12 volts, I need 20 batteries. Yeah, I can do the same drawing with batteries of 6 volts or with batteries of 8 volts. It's very common in golf carts, and that depends on the area that you have in your boat, depend on the space that you have in your boat, and depend of the money, because you can take the decision of lithium batteries or AGM batteries, are good solution, or lead acid. That's your decision, depend on you. All right, this is the procedure to calculate the group of batteries. All right, we are going to analyze the shafts. Once again, we have 3 shafts. This is the input shaft, and the input shaft is connected here with the friction plate, and this is the output shaft that finally is connected with the coupling. You remember that. All right, perfect. And once again, the blue gears in these pictures, they are spinning free. Only if the purple color with the lateral teeth engage on the lateral teeth of the blue pinions, that pinion engage, and of course engage with the red one, because the red one is always spinning at the same speed that the green. The input shaft is spinning at the same speed with the light shaft. We have 3 shafts: input shaft, counter shaft or light shaft, and output shaft. The output shaft in this particular case is the yellow one, the input shaft is the green, and the light shaft is the red one. The light shaft or counter shaft is in permanent contact with the input shaft. It's spinning at the same speed that the input shaft. Okay, remember one thing. If this is the case of the transmission, we have oil at this level. In other words, when the gears are spinning by a splash, the oil lubricate the rest of the gears. This particular transmission, the manual transmission, doesn't have oil pump dedicated to circulate the oil. Alright, this is the situation. We are in neutral. And we are going to start, we are going to refresh quickly in this picture because I put the light shaft in this picture on top. In this particular picture, on top is the light shaft. The input shaft is here. And the output shaft is the blue one. Right now, with the first gear. Alright, this is the situation with the first gear. In the first gear, the dog collar here engage with this gear and produce the first gear. If you check in this particular case, remember that this shaft is spinning at the same speed that this shaft. Alright, in this particular case, this is the multiplier. We have a small driver gear connected with a big driving gear. What is the meaning of that? I am going to multiply according with this ratio between the red one and the blue one. We are going to multiply. This is the gear. This is the maximum gear ratio. The small driver gear with the big driving gear. All right. For that reason, that one will be the first gear, and after that, the second one will be this one, a little bigger driver gear and a smaller driving gear. This is number 2. And after that, we are going to engage third gear, a little bigger driver gear and a smaller one. And number 4 is bigger driver gear and a small driving gear. Okay, we are going to analyze what happened. Okay, this is number 4, and we are going to return. Alright, neutral, number 1, number 2, number 3, number 4, and neutral. Once again, that's the first gear, that's the second gear, that's the third gear, and that's the fourth gear. Once again, first gear, second gear, third gear, and fourth gear, and once again to neutral. This is the transmission. If you check, when the purple engage here, you have the first gear. When the purple engage in this one, you have the second gear. When the purple engage here, you have the third gear. Or here, you have the fourth gear. Or this one, the last one here, the 5th gear. Or if the last one engage with this and this one have a gear in between both of them, you engage reverse. That's simple. This is the manual transmission. Today we are going to talk about the hydraulic clutch or a torque converter. Too much people confuse the torque converter with the clutch pack. It's different. It's different. They engage at the end, but the mechanism is different. Danny, the same like you explained to me a lot of things in relation with outboards and lower units. Today I am going to explain to you the torque converter.
Awesome, I'm ready to learn.
It's a hydraulic clutch. Look, this is a mechanical clutch, Danny. It's a mechanical clutch. You remember? The pressure plate,
Yep.
the friction plate, and the flywheel.
Flywheel, correct.
And the friction plate is moving free. Is here enter the input shaft of the manual transmission. The input shaft of the manual transmission is connected here, always, 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 and is free. Is free if the clutch pedal is applied.
Right.
If the clutch pedal is applied,
It's engaged.
it's free. It's free. If it's applied, it's free, and the transmission is separated from the engine, and you can change the gear. No?
Right,
All right.
absolutely.
But when you release the clutch plate, this element, that metal pressure and the pressure with the friction material connect with the flywheel. This one connect with this and this when you apply, like the video that you have on the screen, when you release the clutch pedal. When you release the clutch pedal, the pressure plate
the friction plate and the flywheel are connected together. In other words, the input shaft of the transmission right now is spinning at the same speed of the crankshaft of the engine. In hydraulic systems, we have this element, and this element is the torque converter.
Correct.
And the torque converter internally have a similar mechanism that the mechanical clutch. The body, the housing of the torque converter is bolted on the flywheel. For that reason, the first step when you try to remove an automatic transmission is remove the start motor.
Right.
Remove the start motor, and through the whole of the start motor, you have access to those bolts
To undo.
in
Right.
order to release the torque converter. And right now, you can remove the bolts of the bell housing and you can separate the transmission.
Nice.
In order to understand easily the hydraulic clutch, we need finish with the mechanical clutch. When the thrust bearing, this is an axial bearing, this is a bearing, axial bearing, and this bearing is moved by the fork, and the fork with your pedal.
With your pedal.
The pedal.
So when you
Press.
press, it
The-
releases.
no, when you press, this metal goes here, and the friction is free.
Free. Okay.
All right. When you release the pressure, this metal goes forward and compress the friction discs, and the transmission and the engines are engaged.
Cool.
Okay. That depend of the thrust bearing. Suppose, Danny, that you have two fans equals, one in front of the other one. One fan is disconnected from the power, and the other one is connected to the power, and I start the fan right now, and the fan start to move. What happens if I put this fan in the maximum speed? What happened with the second fan?
It'll start moving.
The second fan start to move. What happens if I increase more and more and more the speed of this? What happened with the second one?
It'll start moving faster.
Faster, and try to move it.
Move, that's
Try to move it because it's too much pressure on the air coming from this fan.
Right.
Once again, I have one fan here in front of this, and only this one is powered. The other one is
So
free.
that one's the only one that moves all the time.
Correct, this one.
Okay.
And in this one, I can increase or decrease the RPMs
Right.
with my gas pedal.
The gas pedal.
Okay, I increase or decrease the speed on this, and what happened with the second one? At the beginning, it start to spin.
Right.
And fast. If I increase the speed too much here, the second one move forward
It's moving forward.
because it's too much pressure. That's the situation.
So that's what you're just converting that torque. Now that's why they saw a torque
Torque
converter.
converter.
Right. Nice.
Nice,
Awesome.
no? All right, and now we are going to check how is the mechanism internally.
Yeah, I've been waiting for this part because I've been dying to see what it looks like.
Okay, all right. Remember, we have one shaft entering here, and that's the shaft that enter here, no?
Right.
But that shaft is hollow,
Hollow.
and the oil return to the shaft into the oil pan of the transmission.
Right.
All right, okay. Look at this. This is the housing of the transmission. Remember that this housing is bolted on the flywheel, and you have access to those bolts if you remove the start motor.
Starter motor.
Okay, that's simple, the procedure to remove
Right.
this one. Okay, and if the shaft enter here, you have an O-ring over there. All right, that's
Right.
important when you remove the torque converter. Be careful with that O-ring. Normally the color is orange. Okay, now I am going to disassembly, and we have two turbines. One turbine that is welded on the housing. Look at this. This is welded.
Right.
The material is an special titanium steel. It's
wow.
You see that the
Yeah.
quality of
It's
is exactly
amazing.
the same like the turbo in aviation.
Wow.
All right, it's a turbine with the blades in one direction.
Right.
With the blades in one direction. And look, the oil enter here, and this element, this is the stator, this element help to introduce the oil on the blades. Right now I am going to explain. And okay, this is part of the housing, and this turbine is welded on this housing.
Is this one that's constantly moving?
It's constantly moving because this is
This is
solid.
attached to
This
the
is solid
flywheel.
and it's attached to the flywheel.
So that's the one that moves. So that's like that
Correct.
fan you were talking about.
Correct.
Is the first
This
fan.
one is this.
Right.
This
Okay.
one is this because it's moving at the same speed of the engine,
Right.
at the same RPMs. Okay, look at this. This one is
Is the other fan
is
you were
free.
talking about? Right.
This one is this. Look, this one is this.
Right.
Look, this one probably engage with the housing because in the back, this one have a similar element like this.
Yeah.
Look, this is the friction material, copper friction material, and those are the springs, flex, and this is the housing, and this housing is bolted with the flywheel. Once again, I am going to put it back here. And this element is completely free. Okay, what happens if the fluid coming out through this, the name of this turbine is the pump,
That's the pump.
because pumped the oil.
Pumps the oil.
Okay, this one is spinning at high speed. If the oil enter here, the oil enter over there at high speed and high pressure and return here through the middle and return into the oil pan. Okay, look at this. What happens if the speed of this element increase a lot? The fluid enter here at high speed and high pressure, and suddenly this element engage with this.
So it's all due with hydraulic pressure.
Correct.
So with the centrifugal force of the converter forces that pressure, causing it to engage.
Correct. It's basically for centrifugal force.
Nice.
And now this one is engaged with this, and the input shaft of the transmission that is connected with this. The input shaft of the transmission is connected with this. Right now, the input shaft of the transmission is spinning at the same speed of the flywheel. That's it.
Yeah.
Finito.
Amazing.
This is the principle of the planetary system, the planetary gear system. Yes? Because in this particular case, I want the gear ratio in between this and this. Okay, I am going to stop the middle one. I want the output, the gear ratio in between this and this. I am going to stop the sun. Depending what gear ratio I wanted, I need to stop one of those gears. The ring, the planets, or the sun. Yes, the yellow one, this in the center is the sun. The blue ones are the planet, because in some cases you can design that system no with one gear, probably with 3 gears, other one here and other one over there, separated 120 degrees, and you have 3 gears. And this is a planetary system with 3 planets. There are planetary systems with 4 planets. What is the advantage? If you have more planets, it's more accurate, less sound, more precision. With 3, the sound is a little higher. With 2, is higher sound. But yes, you have a planetary system with 2 planets, the sun and the ring. Or with 3 planets, the sun and the ring. Or with 4 planets or 5 planets. Yeah, that's the design. Each manufacturer use 2, 3, or 4 planets normally. That's the common combination. This is the perfect situation. We have the yellow shaft inside of the blue one, and all of them are hollow. The yellow one, the fluid in the yellow one can pass internally through this point. With respect to the last one, to the green one, we can install the shaft. We can design the shaft for the green one here, connected to the triangle, to the link, and this shaft, of course, will be hollow. In this particular case, we have 3 shafts completely aligned. or you can put all of those 3 shafts one inside of the other one. This is the magic secret of the automatic transmission. And of course the fluid is passing internally. The fluid enter over there, and the fluid pass completely through the pipes, through the shafts of the planets or the sun or the rings. Okay, the planetary gear is a set of gears: the sun, the planets, and the ring. Those elements can be combined together in this array. The sun, the planets are connected together, and the ring. Each set of planetary gears produce 2 gear ratios underdrive in forward and 2 gear ratios overdrive in forward. Each couple of gear ratios, underdrive or overdrive, one is useful and the other one unuseful. Let me explain what is the meaning of that. What is the meaning of underdrive gear ratio? An underdrive gear ratio is because the output shaft turn is lower than the input shaft. This is underdrive. Typical example that the output shaft turn is lower but high torque than the input shaft. One of those gear ratios produced in underdrive is useful, first gear. The other one is less speed and a lot of torque. That's practically impossible. For that reason, one is useful, the other one is unusable. The same with overdrive gear ratios. What is the meaning of overdrive? Is that the output shaft is spinning faster than the input shaft. Yes. For example, 4 gear, 5 gear in a 5 speed transmissions or 4 speed transmissions. What is the meaning of that? The output shaft turns faster than the input shaft. The gear ratio is 0.75 turns of the crankshaft produce 1 turn of the output shaft. Okay, this is overdrive. This is the most common. This is the most useful. Other one, 0.5 rotation of the crankshaft produce 1 rotation in the output shaft. Oh, that's too much. It is not useful. The other one, 0.2 rotation of the crankshaft produce 1 rotation. That's crazy. Those are crazy. Those are unuseful. This one is useful. The first one, 0.7 to 1. This is the most common for overdrive. In other words, in a typical planetary gears, we have 2 gear ratios for forward, 2 gear ratios for forward, and 1 gear ratio for reverse. 2 gear ratios for forward and 1 gear ratio for reverse. For that reason, in a typical automatic transmission, you have one set. Suppose that the transmission is 4 speeds, 4 speed in forwards. I have 1 planetary gears for 2 gear ratios, and other one in tandem for the other 2 gear ratios. That transmission internally have 2 sets of planetary gears because it's 4 speeds in forward. And in one of those is produced the reverse. And right now I am going to explain how is the process to produce first gear, second gear, direct drive. Direct is 1-to-1 when the transmission, the input shaft and the output shaft are spinning at the same speed, 1-to-1 direct. Or overdrive like this. Yeah, I am going to explain right now how is the process to produce those gear ratios with those planetary gear set. How is that internally work the system to produce those gear ratios. This is the shaft with the clutch pack for forward. This is the input shaft. In this moment the input shaft, and this is the gear
that engage with the gear of the output shaft with the coupling. This gear engage with this gear. In this moment, because fluid is not entering here, the input shaft is not engaged with the output shaft. The output shaft in this moment is stationary because I don't have pressure of fluid at the input. I don't have fluid entering at high pressure over there. When the fluid enter here, because this one is selected in forward, the body of valves, the fluid enter here, pass over there, and immediately enter in the closed pack. In the closed pack, I have a set of friction discs with stainless steel separated. I have friction plate, stainless steel plate, friction plate, stainless steel plate. I have like a 15 and 15 or 20 and 20 depending of the closed pack. Those elements are located internally here. If you check those plates, the friction plates have the teeth internal, and the stainless steel plates, they have those teeth externals. In other words, I have one shaft connected internally with the friction discs, and I have other case connected externally with the stainless steel plates. For example, with this shaft are connected the friction discs, and with this gear are connected the stainless steel gears. In this moment, the friction discs and the stainless steels are free because we don't have fluid in between both of them at high pressure. When the fluid enter over there at high pressure, the fluid immediately connect both plates, and this shaft with this shaft are connected together. When the fluid enter at high pressure internally, close the discs, and this shaft are connected together immediately. In this moment, because I don't have fluid, this shaft rotates free with respect to this. This is the function of the closed pack. The closed pack, when the fluid enter and compress, connect this gear with this gear. Each set of planetary gears produce different gear ratios in forward and reverse. This is possible because you need to stop the sun and rotate the planet and the ring, or stop the ring and rotate the planet and the sun, or stop this and this, or stop all of that. The process to stop one gear with respect to the other ones is by means of the closed pack or by means of the servo valve. For example, normally to stop the ring, this is the set of planetary gears. And this set, the ring is here. This is the ring. I enter here into the ring, and the procedure to stop the ring, this element, is with the servo band. The servo band have friction material here, the same friction material used in the closed pack. You remember, in the closed pack you have friction material, friction discs with the teeth internals, and stainless steel, friction material, stainless steel, friction material, stainless steel. In other words, the closed pack, one shaft is connected with the internal teeth of the friction material, and other shaft is connected with the teeth of the stainless steel plates. When the fluid enter at high pressure over there, compress the plates, and this shaft is engaged with this. This is the closed pack, you remember, in the previous example. The servo band is the same friction material with a stainless steel band. And this element is externally on the ring, is located externally on the ring. And this element is activated with a solenoid. the solenoid close or open, and you stop the ring or lose the ring. In other words, the servo band is activated for a solenoid in order to stop or lose, stop or free. This is the procedure with the servo band. And once again, the secret is the material, the friction material, and the quality of the oil. If the oil is a dirty oil, eroded the material, the friction material, the enemy of that friction material is the water. For that reason, you need periodically check the color of the transmission oil. Verify if the color become brown or if the color is milky. You need immediately flush the oil, replace the oil, and verify where is the intrusion of water in the transmission. The enemy of the transmission is the water.